Okay, so today we are going to talk about, or we are going to build simple baseline forecasts for Amtrak ridership, validate them on the last 12 months, and then we will be forecasting the next 12 months. So at the beginning, let me load the libraries. So what we need Sybil. Sybil we need it for the tidy time series. And we need Fable. This is for the model or building the models. And also we need tidyverse library. Oops. Tidyverse. This for wrangling plots, etc. Right? Reading tables, reading whatever. Also, I would like to warning false messages false. Let me run this. So I think everything is all right. So now let's go to read the data. So I'm going to read the data. Read data set, right? So we are going, Amtrak is already here. Remember that I am in my, what's so called, project. So every time you have to create a new project to have a neat work. Also make sure that your data is within your working directory, okay? So I'm going to call it Amtrak data. So read, it's CSV. Someone's going to tell me probably, is it underscore or dot? So .csv is going to use utils library. Underscore is going to use reader library. Both of them should be fine. Any library, there are many functions that you can find them in different libraries, okay? Data.csv. So I run the data, then I have the Amtrak. Again, it's a good idea to avoid having the warning and the messages if you're creating the report at the end. After that, I am going to change the data to time series dataset. So create Sybil. So we're going, if you look at the data, we know that the data in advance, we know that it contains months. So we have monthly data, right? We have monthly data of the riderships. I did not save the file yet, so I have to save it. This is evaluation measures, okay? So create Sybil, okay? We have two columns, months and ridership. So the month is going to be, I'm going to convert it to year month as an index, right? To do that, we're going to call it Amtrak, to be honest, okay, Amtrak series. So I'm going to load my Amtrak data. So after that, I'm going to mutate. I'm going to change the month variable. So I'm using a mutate. It's capital letter. It's named, it's already here, capital letter M. So I'm going to change this, the whole column. This is going to be year month of the month, okay? After that, I want to make sure that this is Sybil. So we did this before, and the index is going to be my month. So this is my Sybil data set, okay? After that, what we are going to do, we are going to plot the time series just to explore what's happening, okay? So plot. I'm going to use ggplot here using ggplot. So ggplot is going to contain how many levels? The base level, which is the ggplot. After that, we're going to add the line that's connecting the points, and we can add the labels and Y limit. If you like, you can use then any theme. So ggplot, my first argument is my data. Then we do the mapping. So the data, then the mapping, which is the AES, okay? So my data is going to be, do we need to write data equals? There is no need to write data equal or mapping equal. In some functions, we have to do that. In some, we do not. So you trial and error, okay? So Amtrak time series, we're using the time series. The AES, we're mapping what to what? We're mapping the months to what? To the ridership, right? After that, we are adding another level, which is do the line, a geom line. So connect these points with line. Also, you can add any other general stuff. If you'd like to add the labels, you can add the X label and the Y, okay? Also, you can add the title, you can add anything, subtitle. The theme I'm using is whatever. So let's use the minimal as usual. So this is my time series. This is line plot ridership. The goal is to see the trend seasonality. And it's clear that we have a yearly seasonality. As we said before, we have peaks and the troughs all over the line. Okay, we recognize that this trend is not straightforward, is not increasing all the way. It looks like a curvy. It takes a curvy. Maybe it's a squared, or it's it takes the parabolic shape, right? So we are aware of this, but we are still the beginning of the class, so we're going to develop this later. But we're going to choose the baseline model. We're going to do which is the naive Bayes, right? The naive Bayes. We're going to talk about this in a minute. So we know that we have seasonality. We know that there's kind of a trend happening here. Now, the next step is we will be to do the evaluation measures. We are going to split the data. We're going to split the data or partition the data. So we're going to do the traditional partition. We'll not be doing any advanced partitions now. Partition the data set into training and validation. And we are going to hold the last 12 months as a validation set. And we are going to train the model into the first set of data until last 12 months, because our forecast horizon is 12 months. So I'm going to leave my last 12 months as a validation set. So we can do the traditional one in a very easy way, in a very straightforward way. We can define a variable called, let's say, validation V. Let's call it V less than or equal 12, not equal, equals 12. Then we can find number of the track data, number of rows, how many rows we have. So again, to see what does this tell you, it tells you number of rows. Okay, so run this. So you have 159 piece of information, piece of observation. So you have 159 observation. Okay, we're gonna take 12 out of them. 12. Okay, so the number of the training data is going to be, technically, is n total minus V, simply, right? So how many training, okay, how many training and train, let's say, we have 147. So we are going to take the first 147 piece to be in the training data and the last 12 to be in the validation data. Now, let's split. Now we are here we just define the numbers only. How many observations do we need for the training? How many observations do we need for the validation? Okay. So how to do training? I'm going to define my training. I'm going to take the data from Amtrak first, time series. Also, I'm going to use a function called slice head. So pipe. I'm using pipes here because I'm passing Amtrak time series. I'm going to take some numbers, okay? So slice head, and I have to specify the number of and how many P's do you want to take? The head, the first one, first numbers, the first few observations. How many numbers do you want? 147, right? So it's not recommended to write 147 because this is going to be changed if you have different data sets. So it's good to have the variable that represent this number, which is ntrain, number of the training data. So this is going to represent my training data set, right? This is going to represent my training data set. We can run this if you like. So train, look at the train. We have 147 observations of 2 variables. And because I use the slice head, that means we are using the first or top hand, not the largest, in order, 147, the first 147. Also, you can do the validation data set now. We can do the same thing, but not the slice head. I'm going to use a slice tail. Do we have any other methods? Yes, we have tens of other methods can be used to partition, by the way. Slice tail. Well, I assume this is one of the easiest way to do the traditional. So I'm using the tail 12, n equals V. So now I'm defining the validation data set. This is the last 12, which is from April 2003 to March 2004. The training, it's from 1991 Jan until March 2003. So we are using this now. After doing the partitioning, now let's train the model, the base models. And I'm going to do both base models, which is the naive base, which is the last observed value, and the seasonal naive, which is the value that from the same month last year. Okay. So let's do create baseline models. So we're going to do both naive and seasonal naive. Okay. Okay. To do that, I'm going to use a function called naive and function called seasonal naive. Both of them are from Fable, I guess. So let's fit the model. So I'm going to say this is the fit base model. This is going to be my model, okay? And because we are fitting the model into the training data, we're gonna call training data. Then pipe, I'm going to do the model. The first model I'm using is the naive. I'm gonna call it naive. It's not healthy to use the same name, but the function called naive capital. So there's the difference. Also, or you can call it naive model, just to avoid having same. And I'm modeling the ridership. I have only one variable here. Also, I'm going to have another model. This model, we can build multi-models, by the way. Seasonal naive model, S naive, also ridership. Also, you have to define the lag. This is for how many months? So we said 12 months is seasonal, right? So I think this is fine now to fit that model. So now we have the fit base model is there already. Okay, after that, we are going to, after creating both models, we are going to forecast the validation set, the data that we have not seen before. So the model was built based on the training data, and we did two models, the naive and the seasonal naive, and the lag is 12 months or a year. You can change it to year, or you can change it to V, I guess. So you can do any. Let me V. This is gonna work, or even you can use year because our data is indexed by months. So you can use any. V is okay, I guess. So the lag 12 means we have 1 year, and forecast each month using the value from 12 months periods ago. This is for the seasonal. So after that, what we have, or what we are going to do, we are going to forecast the validation set, as we said. Forecast the data that forecast the validation set. So this data, which is the last 12 months, have never been seen by the model. So the model doesn't know it. We are going to calculate. Let me create a chunk. So I'm going to forecast base. I'm going to call it base. So these are baseline. We talked about this in the presentation. The baselines are naive. We just repeat the last value. For the seasonal naive, we repeat the last month, the last month, equivalent last month from the last year. So I'm going to do what? I'm going to go to the model first, the model that we have built. I'm going to drag it to use it. So use fit base model. This is the meaning of that pipe. Use fit base model to forecast the validation set. Forecast the validation. So create some forecasting for the validation. You can call it new data. New data equals validation. Also, we can look at this. Let's look at this. Okay. New data equals valid forecast. I missed the E here. So we have a 12. This is a Fable 24 times 4 because I have naive and seasonal naive. We have one key. Now we have I'm going to look at the mean. So this is my model. These are my months. And these are the point forecast. This is not the mean, the average. No, this is the point forecast. And forget about this one because this is kind of a normal distribution. This is the mean, this is a standard deviation. This is normal mean standard deviation. I'm not going to speak about this now. Well, let's talk about this. This is my forecast, and we know this. If you look at the last observation of the training, so this is 26.6. So this is repeated. This repeated here for the entire 12 months. For the seasonal, no, we back 1 year ago. 1 year ago, okay? Last year for the seasonal. 2002 April is the same as this. 2002 May is the same as this. 2002 June is the same as this. So on, right? So this is my forecast, and actually we can just join them and see and join what we have in the validation. So let's join the actual values and the forecasted one, right? And let's find the error. Find the error. Okay. So let's do all of this quickly here. So what I'm going to do, I'm going to call it forecasting error. And I'm going to bring this time series, this one. It's a fable. So I'm going to base. The name of this table is forecast base. I'm going to change it to tibble so I can use dplyr libraries verbs easily. So I'm going to change this as tibble first. Then I'm going to do what? This is something that we do with data wrangling, by the way. This is data wrangling. So I'm sure that you have done this before in other languages like Python. So at the beginning, what I'm going to do, I'm going to choose them. I need this column. I need this column. I need this column. I'm going to change the title of this to be forecast. I don't want this guy. So I'm going to take it off. Okay, this is number one. So I'm going to select. I need the model. I need the month. I need the mean, but I'm going to call it forecast. Just to give it a name. Okay, forecast, maybe small letters. After that, so what I'm doing, I'm creating a new table called forecast error. After that, I'm just calling that table. This table, I'm changing this to table so I can use select easily and left join and mutate easily. Then I just pick the first 3 columns out of this, not all of them. After that, I'm going to join this, left join. I'm going to add data from the validation set, okay? And this will be by months because I want this to match. So I'm bringing the actual data from the validation, and I would like month to be the variable that is going to match the data set from both sides, from the validation and the the FC base. So you have a table here, we have a table there. So the month is going to be has to match. They both have to match by month. Does that make sense? This is one of the joins things that we normally do. Also, I would like to add the error. I would like to mutate a new variable called error. Mutate. I'm going to call it error. Error is going just to subtract ridership. Remember, ridership is a variable exists in the validation minus the new variable that we create. Not the new, it's the forecast, the mean, this one. So I'm just subtracting the ridership from the validation and the forecast. But now someone's going to tell me, oh, this is in the validation, this is in this set. No, we gathered them already. We joined them, so they're here now. As tibble, I have an E here. Okay, here we go. Then I can look at this guy. So now I have the model, I have the month, I have the forecast. It's a table now. It's not fable or table anymore. This is the forecast. This is the ridership. This is the error, just subtraction. Ridership minus the. We can rearrange them, by the way, using the function rearrange. This is the naive, seasonal naive, and so on. So these are this is the table now. I can look at the histogram of the errors, right? So let's plot the histogram and see whether we have, like, get an idea about whether we have a a normal distribution of the errors, or they are not normally distributed errors. So let's look at the histogram. of the forecast errors. So I'm going to look at the distribution of the validation errors. Again, we have 12 of them, right? And we are going to, we have the new variable or the new table that we have, which is the error, right? And I'm going to create ggplot. Just I'm going to have a of the errors. So I'm going to take only the errors from there. Only the errors, okay. I'm going to add geom histogram. You can create number of bins. Maybe you're gonna have 10, 15, 12. Let's try 15. You can give it a tab. You can add the labs if you'd like to get a name, the title, whatever. So let's add labels. Title, you can add, this is validation error. I have to add quotations, errors. If you'd like to add X and Y, you can do so. You can X represent the errors, Y represent the count. I think this is fine. If you'd like to add the theme, you can do so, but that's fine. So it's not normally distributed. This is number one. The errors are not normally distributed, right? So I have outliers here in the errors. Most of them are positive, right? Even if you change from 15 bins to 12, nothing is going to change. We still have, you can still work on this, by the way, kind of the appearance, but there's no need to do that. Anyway, so the next idea is to find the evaluation measures. This is the goal, right? So the goal is to look at the evaluation measures. Again, we are looking for the evaluation measures on the validation set. So these are the accuracy measures, okay? So we are going to look at, okay, the accuracy measures, we are going to look at the forecasting base. This is the table that we did the forecasting, right? So we're going to grab this. After that, we are going to do accuracy on them. So we have a function called accuracy, just accuracy. The accuracy, we are going to compare the data from this one. We are going to grab this and look at the Amtrak data. So the data will be, so the first argument in the accuracy is going to be your original data. So Amtrak time series, comma, and what are the measures? Because I have lists of measures, I'm going to use measures. I'm going to call it measures equals list of the objects. So I'm going to give, you can say SE, MAPE, and so on, but we can give them names as well. So we can call them, you can keep the same names, MAE, that's okay. RMSE equals RMSE, comma. We can have the MAPE, comma. ME, or ME. What else? There's something which is ASE, the one that we discussed, right? So we do have the accuracy measures now, and we can run this. Before run this, let's also call it accuracy measures. AE. Okay, here we go. So we're looking for lower values. Lower MAE, RMSE, MAP, MAB, right? MAPE, sorry. So if you look at which one has give you lower values is the naive. So the naive wins here. All of the values are less, right? Okay, we know that the seasonal naive Malux for us when we did the base plot, we see that, oh, we have a seasonality, we have strong seasonality. So we're expecting the seasonal time series is going to be better. The seasonal naive base is going to be, or naive model is going to be better, not base. But, oh, so it's going to help us maybe, but not now. But for now, we see that the naive model does better job compared to the seasonal naive, okay? So what we have to do finally, so because we have chosen that, we can say that here naive base wins or whatever, or we are going to choose naive base to do the forecasting over the entire data set. So what's the conclusion? We can say since naive gave smaller errors overall, we will refit the naive or naive without the on the full data set and forecast after that, then forecast the next 12 months. Okay, so we are going to fit the model again using naive. After that, we are going to do forecasting for the following 12 months. So let's refit. So refit is going to be, refit naive on all data set, because this is the goal all the time. Final fit. Okay, final fit. I'm going to Amitrack data set. We're going to model naive, final naive model, which is going to be naive from, not for the test or validation, whatever, it's for the ridership. Again, it's ridership here. It's not here, not the validation or training, sorry. It's for the whole Amitrack. We're going to fit the naive. Okay, so we've done this final fit. Also forecast next 12 months. We're going to do the same thing. Forecast next 12 months. Final fit. So I'm using final fit. Okay, to forecast. H is going to be my 12 months. Okay, my 12 months. If we go up, we did the forecasting on the validation set. Now because we have a validation set, now we do forecasting on H equals 12 months. So the next 12 months. Let's do this. And after that, let's see them. Let's maybe properly use the auto plot. Let's plot the forecast with prediction intervals. Auto plot forecast next 12 months, right? Also, I would like to have my Amitrack dataset. We're going to add titles. Also, we're going to add, this is the final or next 12-month forecast using naive model. Do we need to add let's add X. What X is going to be the month and Y is going to be as normal the ridership. Let's see. So the autoplot give me the prediction intervals, the 80 and 95%, and this is the whole Amitrack, right? And we can conclude this. We can do a conclusion here. Let's do a summary. So to summarize this, so before I do the summary, by the way, if someone's going to change these levels, you can change the levels from the tier level 95, let's see. Yeah, probably let me do 80 and 85. So I added the level to the auto plot. So we have 80 and 85. You can change it to 90, 95, or 90, or whatever prediction level you're looking for. So back to the summary. What we did, we compared two base models, technically. Forecasting, both of them are forecasting models, right? For Amitrack dataset or ridership, whatever, ridership. What are the two models? The naive model, what does naive model do? It uses the last observed value as the forecast, and the seasonal naive model that use the value from the same month the previous year, right? Previous. Okay. We expected, actually, although we expected the seasonal naive model to perform better. Why we expected this? Because we have an obvious seasonality due to having yearly patterns, yearly and strong seasonality, right? What has happened? Although we expected this going to happen, but the validation results show otherwise, right? what happened, naive model achieved lower errors. In general, lower errors. Not in general, across all of them. Across MAE, SE, MAPE, what else? SE, did I miss something? All of them. And showed, I think this is fine. So based on this, naive model is a stronger choice. We, after that, or then, or after that, therefore refit naive model on the full data set and used it to generate forecasts for the next 12 months. So maybe this is kind of the summary probably we are going to have. This is something very simple, just using naive seasonal naive. And also we can repeat, by the way, we can look at after refit and doing the forecasting. Now the question is, can we find the evaluation measures now? Can we? No, we can't, because what are we going to compare the forecasted value with? We do not have the actual values for the next 12 months. Once you have the actual value next 12 months, you can now do the comparison and find the error. So this is almost everything. And that's all for this example now. Thank you.